So today in this class we are going to discuss what you already know actually. Since class 11 physics you have been studying about vectors. So in your NCERT class 12 maths we have a chapter known as vector algebra, okay, or we can simply call it as vectors. So your NCERT class 12 chapter 10 vector algebra, vectors. You already know what is a vector. So if I ask you what is a vector, then like how exactly are you going to define vector? When I say vector, already you know what is it, okay? But like how are you going to define? Yeah, it's a physical quantity, a physical quantity which has both magnitude as well as direction. That is a vector quantity. If I list out some physical quantities around 10, 15, 20, okay, 60, 100, then you can easily identify which are scalars and which are vectors. So let me skip that introduction, okay? I want to focus on representation of vectors. How do we represent a vector? That's very important. Representation of vectors. Just vectors, the simplest way is like a physical quantity which has both magnitude and direction is a vector. Okay? And you can give some examples on that. So I'm not going to waste time on that. Let me start with representation of vectors, okay? What is this? What is this? A line, okay? A line. Name it as AB, okay? The endpoints of this line, you name it as AB. Till class 10, we studied that this is simply a line. But now we are going to study in this way. If it is a line, okay, then where is it directed? Is it directed towards B? Or is it directed towards A? No. If it is a line, then it must have a direction. So is it directed towards B? Or is it directed towards A? So directed lines. So these are directed lines. Till class 10 you studied, okay, you draw a line. You don't care where is it going. You don't care where is the initial point. You do not care where is the terminal point, right? But now, even when we draw a line, then you must be concerned about the direction. Whether is it directed towards B or is it directed towards A. So these are known as directed lines. So vector means directed lines. Is it okay? So this vector is your directed lines. In the first case, the line AB, this line is directed towards B. So A is going to be your initial point and B is going to be your final point. Okay? So this directed line should be represented by the vector. The name of this line is AB. Okay? Where the initial point is, this line is AB and it is directed towards B. So I'm going to represent this line, directed line AB, as vector AB, where A is the initial point, B is the final point, terminal point we say. Not final point, terminal point. The line terminates at B. Starting from A, it terminates at B. Okay? Similarly for this line also, for this directed line, here the line is directed towards A. So B is your initial position and A is your terminal position. So this directed line AB can be written as it starts, the initial point is B, the ending point is A, terminal point is A. So this directed line should be represented by the vector BC. Is it okay? Yes. So this is how we represent a vector. Suppose in the second case, okay, this directed line there starts at B. B is the initial position and A is the terminal position. You cannot write A, B and direct it towards it. You cannot write in this way. Okay? Yes. The arrow should, when you denote a vector, the arrow should always point towards the right side. Is it okay? But you have to write which one is the initial position, which one is the terminal position. That's all. So for this vector, for this directed line, the vector representation will be initial point is B, so you write B first, and terminal point is A, so you write A. See? So this directed line is represented by vector AB, and this directed line is represented by the vector B. Are you getting me? Suppose for any directed lines, suppose if this is your directed line, okay. Suppose you have another line, X, Y. Suppose this is a directed line. So this line is directed towards Y. So directed line. So the directed line, okay. So this directed line, it will be represented by the vector. The initial point is X, right? Terminal point is Y. So this directed line will be represented by the vector XY, where X is your initial position, Y is your terminal position. That is how vectors are represented. Okay? Directed lines. Vectors are represented by directed lines. Alright? Yes. The next one is position vector. Position vector. Let's study what is this position vector. Suppose there is a position. Actually, I wanted to write position vector. Suppose you have a point P in space. If a point P is in space, it is at some distance from the x-axis, it is at some distance from the y-axis, it is at some distance from the z-axis, right? So what will be the coordinate of that point? Just in general. If a point P is in space, okay, then what will be the coordinate of P? Yeah. So let me draw a three-dimensional coordinate system. This is your three-dimensional coordinate system. This is your x-axis, this is your y-axis, this is your z-axis. This is the origin, right? If you consider a point P here in space, okay? I cannot. Let me just write it here, okay? Since the point P is in space, its coordinate will be x, y, z. If a point P is in xy plane only, then its coordinate will be only xy 0, no z coordinate. If a point is in xz plane, then its coordinate will be x0, z. Okay? But we are considering a point not in plane but in space. So the coordinate of that particular point will be x, y, z. Okay? So position vector is defined for a point, in this case P. So position vector of a point is defined as the position of that point when measured from the origin. Okay? Now, not the distance, okay? Not only the distance, but the position. You are determining the position. Means the distance as well as the angle. It both comes into play. In physics also, we studied about electric potential at any point P r theta due to the dipole, right? Now position, yes. So Considering a point P in space, then its coordinate is given by x, y, z. Okay, x, y, z could have been any values. In general, I have just written x, y, z. That is the coordinate of P. Then the position vector of P is defined as the position vector of P is defined as the position of this particular point P when measured from the origin. So the position vector of this P, point P, will be denoted by the vector OP, where O should be your initial position and the particular point that you have chosen will be your terminal position. Is it okay? So the position vector of P will be represented by vector OP, where O is your initial position and P is the terminal position. Alright? Yes. So if point P, if the coordinate of point P is x, y, z, then position vector of P is the position of this particular point P when measured from the origin. Here, your O is always, the origin O is always your initial position. Your origin, the coordinate of the origin is 0, 0, 0, is always the initial position. And the particular point P that you have chosen with coordinate x, y, z is your terminal position. So the position vector of this P should be represented by the vector OP. O is the initial position, P is the final position. And position vector of this P, denoted by vector OP, should be written as xi cap plus yj cap plus z k cap. Is it okay? Yes. We will come later on what is I cap, j cap and k cap when we discuss about types of vectors. Okay? Let me not highlight anything about that now. Alright? When I come to the type of vectors, then we will, you already know what is I cap, j cap, k cap, but I will highlight you again on the types of vectors. So are you getting me about the position vector? Suppose I want to define the position vector of a point A. Suppose of a point A whose coordinate is x, y, z. Then how are you going to define? Position vector of this point A. It means point A, the coordinate of point A is x, y, z. So that means point P is in, point A is in space, right? Okay. That means A is at x distance from the x-axis. It's at the distance of y units from the y-axis, and it's at the distance of z units from the z-axis. Okay. So these are your x-axis, the y-axis and the z-axis. This is your origin, this is your point A with coordinate x, y, z. So position vector of this point A means position of this A when measured from the origin. You are measuring it from the origin. So O is your final or initial position and A is your terminal position. So the position vector of A is represented by the directed line OA. With O as the initial position, A is the final position, and it is written by the vector xi cap plus yj cap plus zk cap. If the coordinate of A had been like 2, 1, 4, then the position vector of A would be the position vector of A represented by the vector OA will be written as 2i cap plus 1j cap plus 4. Is that all right? It is what is known as your position vector. The next one is direction ratios and direction cosines. Direction cosines. Okay. Let's try to understand what is direction ratios and direction cosines. There are so many ways to explain about these direction ratios and direction cosines. I'm going to let me do it in the most simplest way, just in very few words. Suppose this is your three-dimensional coordinate system, x-axis, y-axis. The whole chapter we are going to only draw this one, okay? This is your origin. Let me consider any point P in space whose coordinate is x, y, z. Then, position vector of this point P will be denoted by vector OP, right? With initial point O and terminal point P. So this OP is this line OP is directed towards P, right? Okay? Yes. Now see, the position vector of P, vector OP, right? Is it making some angle with the x-axis? See? Huh? This vector OP, the position vector of P, vector OP, it's making some angle alpha, say, with the x-axis. It may be making an angle 30, 45, I do not know, I'm just taking alpha. It is also making some angle with the y-axis. Let me denote by beta. And it is also making some angle with the z-axis. Let me take it as gamma. Okay? Alright, clear? Now what you do, you take the cosine, you know, trigonometric ratios, trigonometric functions, sine, cosine, tangent, cotangent, okay, secant, cosecant. You take the cosine of these angles, okay, made by P with this three-dimensional coordinate system, okay. Alpha is the angle made by this vector OP with the x-axis. Beta is the angle made by the position vector of P, OP with the y-axis. Similarly, angle made by this vector OP with the z-axis is gamma. Now what do? You take the cosine of all these angles. So the cosine of these angles, of these three angles, made by this vector OP, made by the position vector of P, is known as direction cosine. Okay, direction cosine means cosine of the angle, alpha, beta, and gamma. And what are these alpha, beta, and gamma? Angle made by the position vector of P with the x-axis, y-axis, and z-axis respectively. That is known as direction cosine. So cos alpha, cos beta, and cos gamma, these are known as your direction cosine. Cos alpha is also denoted by small letter L, okay. Small letter L is also known as cos alpha. Cos beta is denoted by small letter m, cos beta. And cos gamma is denoted by M. So this L, M, N are known as the direction cosine. Okay? Now, let's see what is a direction ratio. In order to determine what is direction ratio, let me drop a perpendicular from P here to the x-axis. Okay? Similarly, I have to drop a perpendicular on the y and on the z also. But let me do it for one, and similarly we can write the result for the other. Ne? So from P I have dropped a perpendicular PR to the x-axis. Okay? Now in this right triangle, POR or PRO, is it okay? PRO. In this particular right triangle, PRO in what I do not know, but it's alright. POR, this is your alpha, right? Cos of alpha will be given by, let me write it here. In right triangle PRO, cos of alpha will be given by base. Don't say base, base is not a good word. Side adjacent to angle alpha, OR. Okay. Let's say that this line OR is directed towards the positive x-axis, so then I will write vector OR, right? Origin should always be your initial position, okay? No matter which directed line you talk about. So for this line OR, let it be directed towards the x-axis, so that O will be your initial position, R will be the terminal position. Upon what? Upon what? Or if you want to take only the magnitude, that is also okay. You can just consider only the magnitude, no problem. Upon side adjacent to angle alpha, that is OR, upon OP is a vector. What vector? Position vector of P, right? OP is the position vector of P. Upon position vector of P, that is OP. Is it okay? So in that case, cos alpha will be, see, OR, what is OR? Some distance on the x-axis, right? OR is some distance, some length of the x-axis. Shall we write OR is x? Some length of the x-axis, right? Position vector of P is given by vector OP. Shall we give just one word? One letter? R vector? Ne? Position vector of P, vector OP, let me denote by vector R, okay? Upon vector R. Alright, cos alpha will be given by that, no? Similarly, cos beta will be given by what? Cos beta will be given by what? Beta is the angle made by this position vector of P with the y-axis. So, cos beta will be given by y upon position vector of P, right? Similarly, cos gamma will be given by z upon position vector. If you take only the magnitude, since I have taken this as this or only the magnitude, so you can also take magnitude only, right? Shall we take only the magnitude? Magnitude low, it's alright. Then in that case, this x, y, and z are known as your direction ratios. Okay? This x, y, and z, the x, y, and z that you have obtained are known as your direction ratios. Now what is this? This is your L, right? Cos alpha is your L, right? This is your M. And what is this? This is your M. Is it okay? Yes. So this x, y, and z are known as your direction ratios. So direction ratios are numbers. They are just some scalars. Okay, they are numbers, they are scalars. Okay, such that they are proportional to this L, M, and N. Is it okay? L, M, and N are known as your direction cosines. So the numbers, this x, y, and z, they can be A, B, and C also. They are three numbers. Direction ratios means they are three numbers. They are three scalars, A, B, and C, such that they are proportional to L, M, and N. Those three numbers, those three scalars are known as your direction ratios. In this case, x, y, and z are known as your direction ratios. Is it okay? Any confusion here? Yes. So in the first and second exercise, we are mainly going to talk about these direction ratios and direction cosines. As we solve things, okay, then it will become more clear as we solve some, do some applications on this. All right? Okay. Shall I explain to you again, or is it fine? It's fine. Now, types of vectors. Types of vectors. What are the types of vectors that you know? Types of vectors. First one, zero vector. Zero vector. Very simple. Zero vector. What is a zero vector? Zero vector means it is denoted by zero. Zero vector. Directed line vector. So what is zero vector? I cannot say that to be correct. Which is direction but no magnitude. Okay, which has no magnitude but can have any direction. তাই도 magnitude 나이도 또 magnitude 단 থাকিলে도 কত ফালে যাইছে না জানিব নি হলে নহয় magnitude থাকিলে হি কত ফালে যাইছে ডিটারমাইন কৰিব পাৰিব তো but a physical quantity it has no magnitude means we can a vector has having no magnitude means zero magnitude we cannot say like where it is going exactly no so for zero vector means it's a vector having no magnitude magnitude নাই magnitude নাই কইলেতো কত ফালে যাচ্ছে কিনাকা জানিব it can go anywhere is it okay yes which is no magnitude that means it can have any direction that is called zero vector okay yes a vector having zero magnitude that means since it has no magnitude so we cannot specify like in which direction where it is directed now so it can go in any direction is it okay it can go anywhere all right yes number 2 unit vector this one we in physics we are studying about only unit vector unit vector till now what is unit vector I think you can answer that unit means what unit 1 magnitude 1 no? So a unit vector is a vector of magnitude 1 okay and we use this unit vector to specify the direction is it okay khali direction denote korobole loine kile kole tai to magnitude 1 ni thakabra all right so unit vector means it has magnitude of 1 unit it is magnitude of 1 unit is it okay and we use this vector unit vector to specify the direction in order to specify the direction of the x-axis and unit vector means suppose if you are choosing a as the unit vector then it has to be followed by a cap denotes this cap denotes that a is a unit vector if you are taking c to be a unit vector then you need to specify by writing a cap this cap denotes that c is a unit vector that means it has magnitude 1 all right yes so unit vector means it's a vector of magnitude 1 and we use this vector to specify the direction so the direction of the x-axis is represented by the unit vector I cap the direction for the y-axis is represented by the unit vector j cap and the direction for the z-axis is represented by the unit vector k cap is it okay that means the magnitude of I is 1 magnitude of this j cap is also 1 k cap is also 1 they have magnitude of 1 and we use this I cap for giving the direction for x-axis a particle is going towards the x-axis so its direction should be given by unit vector I cap suppose a car is going towards x-axis with a speed of 20 meters per second a car is going towards the x-axis with a speed of 20 meters per second then how will you write in vector speed will be given by what 20 meters per second I cap speed of the car will be given by 20 I cap means it's going at a speed of 20 meters per second in the direction of x-axis all right yes okay so also find the unit vector suppose you are asked to find a unit how to find a unit vector suppose find a unit vector in the direction in the direction of this vector Suppose this is your vector B. This is a vector B. Okay? You want to find the unit vector in the direction of this vector. See, this is the direction of your vector B, right? So you want to find out what is the unit vector in the direction of this vector. Then let me say, let B cap be the unit vector in the direction of your vector B. If it was a vector C, if it is a vector C, and you want to find out a unit vector in this direction, okay, then I will write C cap as the unit vector representing this direction. And this unit vector can be determined by vector C upon the magnitude of C. Okay, vector C upon the magnitude of C. This is how we can find a unit vector in the direction of any given vectors. Alright? Yeah. Find a unit vector in the direction of x-axis. Then just write I cap. Is it alright? Find a unit vector in the direction of z-axis. Just write k cap. Okay? But if we are given here, suppose this is your vector A, and this is how it is directed. So you are asked to find a unit vector in the direction of this vector A. Then, what I'm going to write is, let A cap be the unit vector representing the direction of this vector A. Then the unit vector A cap can be found out by using the formula vector A upon magnitude of A. Let me show you how to find the magnitude of a vector. You already know, but okay, just an introduction class here. Suppose your vector A is xi cap plus yj cap plus zk cap. That is your unit, that is your vector A. This is how it is directed. Now I want to find out the unit vector, okay, which represents the direction of this vector A. Then we have a vector A, right? Let me find its magnitude. If this is your vector A, then the magnitude of your vector A will be given by square root of component of x square plus component of y square plus component of z square. Finish. So your unit vector A will be vector A. That is xi cap plus yj cap plus zk cap upon the magnitude of A, which is square root of x square plus y square plus z square. Any questions? Any questions? Is it clear? So in the exercise you'll be doing some questions to find the unit vector in the direction of a given vector. Here I have just represented this directed line by a vector A, right? But you may be asked like this. Suppose there is a directed line. See? So this directed line will be this directed line has initial point A, terminal point B, right? So this directed line will be represented by the vector AB. So you are asked to find a unit vector in the direction of this vector. Okay? Then what I'm going to write? Since this is your vector AB, so let AB cap be the unit vector representing this direction. That means direction of your vector AB. So unit vector AB will be given by vector AB upon the magnitude of AB. Is it okay? Yes. Now there is a thing that we need to do it here. How are you going to find out AB? Suppose A has coordinates 1, 2, 3. B has coordinates 4, 5, 6. Huh? A has coordinate 1, 2, 3. B has coordinate 4, 5, 6. How are you going to find out the vector AB here? Okay. Let me show you how. Again, same old story. I hate drawing this one. This is your three-dimensional coordinate system. Okay? This is your A. This point is your B. Shall we take in general? Coordinate of A is x1, y1, x1, y1, z1. Shall we take that in general? Coordinate of B, x2, y2, z2. And you want to find out vector AB. You want to find out vector AB. That means your initial point will be A, terminal point will be B. So in order to find out this directed line AB or vector AB, what you have to do, first of all, you have to know what is the position vector of A. Position vector of A will be your vector OA, because O is always the initial position. And position vector of B will be your vector OB, right? So vector AB will be given by position vector of B minus position vector of A. Position vector of the terminal point minus position vector of the initial point. Position vector of B means vector OB. Position vector of A means vector OB. Okay? Position vector of B means vector OB. What will be your vector OB? x2i, component of a vector, right? Plus y2j plus z2k minus, what will be the position vector of A? x1i plus y1j plus z1k. So let us subtract them. Only the x component can be subtracted with the x component. So x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 j cap. That is how you can find out vector AB. Once we get vector AB, and if we want to find a unit vector in this direction, then the unit vector representing the direction of this vector will be given by AB cap. AB cap is a unit vector representing the direction of this vector, right? So vector AB, which we have obtained here, upon the magnitude of AB. Magnitude of AB means square root of component of x square plus component of y square plus the component of z square. Is it okay? Yes. So this is number 2, unit vector. Okay. The third one will be co-initial vectors. Co-initial. What is that co-initial? Co-initial. Initial means yes. So co-initial vectors means if two vectors have the same initial point, they cannot have same terminal point, okay? But if two, so number third one, co-initial I and I. See, introduction is very important. That is why even though you know, I'm just explaining again, because once you're done with the introduction and the exercise starts, you can just do it on your own quickly, okay? So once I'm done, you will note down everything and then you can start the exercise on your own. Okay, that you can do it easily. Co-initial vectors means if two vectors have the same starting point, have the same initial point, then they are called co-initial vectors. Suppose, say this is the initial point and this is your vector A. From the same initial point, there is another vector B. See, since the two vectors have the same initial point, they are called co-initial vectors. Alright? Next one, number 4. Collinear vectors. Collinear vectors. What do you say about collinear vectors? Like, collinear vectors means in the same line. No, not in the same line. two vectors are said to be collinear if they are parallel. If they are parallel, they may have same parallel means the two vectors may have the same direction, or the two vectors may have opposite direction. Collinear vectors. Okay. So two vectors are said to be collinear if they are parallel to each other. See, they may have the same direction. Your vector A may be directed this way, your vector B may be directed this way. Direction doesn't matter. Is it okay? But they should be parallel, then they are collinear vectors. Okay? And how are you going to show that they are collinear? If A and B has same magnitude, if A and B has same magnitude and same direction, then you will write A is equal to B, right? Is it okay? Yes. Suppose this is your vector, this is your vector A, this is your vector, these are two vectors. I want to show that they are collinear. So in order to show that they are collinear, what you have to do? You compare their magnitude. Which vector has lesser magnitude? B has lesser magnitude. Are they in the same direction? Yes. Since B has lesser magnitude, so you can multiply the magnitude of B with some scalar. Now, then you will get magnitude of A, right? So if these two are parallel, if these two are collinear, then you can write vector A is equal to lambda times vector B, where lambda is any scalar. Lambda means a scalar multiplying with your magnitude of B, so it becomes equal to the magnitude of A, and they are in the same direction. What happens if they were opposite direction? Suppose this is your vector A, it's directed towards the right. You have another vector B, smaller in length, directed this way. Or the two vectors have opposite direction, right? Yes, in that case, see, since B has lesser magnitude, so you multiply the magnitude of B with some scalar, then you get vector A, but they are in opposite direction, so lambda times minus B. So that is minus lambda B. So this shows that A and B are parallel. In general, I can write A is equal to plus minus lambda times vector B. Vector equal to plus minus. So if you can prove this condition, then you can conclude that the two vectors are collinear. So there may be questions like to show that the two vectors are collinear, then you have to satisfy this condition. Is it okay? Yes. The fifth one, coplanar vectors. We will study that in the end of this chapter. During the end of this chapter, we are going to study that. I don't want to highlight that now. Okay, it will take some time. Coplanar. Just remember that coplanar vectors means two vectors are said to be coplanar if they lie on the same plane. Same plane. Suppose the surface of this board is one plane. If two vectors lies on this plane, they are coplanar. Is it okay? That we will come later. The next one will be equal vectors. Equal vectors. Very simple by the term equal and vectors. So how will you say? Vectors. Two, yeah, you can say.
Vectors which have equal magnitude direction.
Yeah. So two vectors are said to be equal if they have the same magnitude as well as the same direction. Suppose this is your vector A, this is another vector B, then the length of these two vectors must be same, magnitude should be equal, and both of them should be directed along the same way. Okay? So the vectors having same magnitude as well as same direction are known as equal vectors. What about negative of a vector? Negative of a vector. Negative of a vector. Yeah. Negative of a vector means, suppose vector B is called the negative of A if A is equal to minus of B. Vector is equal to minus of vector B. This is enough. Okay? That means the two vectors have the same magnitude but opposite direction. Then we call negative of a vector. Alright? Now, properties of addition. See, addition of two vectors can be done using triangular law of vector addition or by using parallelogram law of vector addition. Okay, let me not explain that to you again because you have already studied in class 11, so I'm not going to say about those two laws of vector addition. Okay, yes. So properties of addition. Let me tell the remaining properties. Properties of addition. Addition of vectors. First one is vectors satisfy commutative property of addition. Commutative property of addition means vector A plus vector B will be equal to vector B plus vector A. So vectors satisfy commutative property of addition. So this is your commutative property. I am feeling so hot. Is it hot? Number 2, okay. Vectors also satisfy associative property of addition. Associative property means if A, B, and C are any three vectors, then vector A plus vector B plus vector C will be equal to vector A plus vector B plus vector C. Is it okay? Number 3, existence of identity. Identity vector. Hey, what do you mean by identity vector? Identity vector means you have to choose a vector so that when you add with another vector, that will give you that vector itself. See, identity vector means vector A added with which vector will give you A itself? Zero vector. So this zero vector is known as your identity vector. Okay? In A vector, when added to some vector, you need the same vector A again, right? So the only option is your zero vector. So this zero vector is known as your identity vector. Okay? And fourth one, additive inverse. Additive inverse of a vector. Additive inverse of a vector. Additive inverse means vector A, which when added to some vector gives you the zero vector? Minus of A. Minus of A. So that is your additive inverse. Is it okay? Means negative of a vector. So, if A is any vector, then minus of vector A, minus of A vector is called the additive inverse of vector. So for the first exercise, this introduction should be enough. Is it alright? For the first and second year, this introduction should be enough. So you can highlight some of those, okay? And then we'll start with the exercises. So the next one is free vector. Free vector. I just forgot that. What is free vector? Vectors, those are free. What do you say, free vector? Last year in physics we have studied free vector. Suppose this is your vector A. There is another vector B here. I want to measure the angle between the two vectors A and B. What you have to do? I can shift this vector to this position. Okay? So that if two vectors are joined tail to tail only, I can measure the angle between them. Those vectors are known as free vectors. Vectors can be shifted through a small displacement, through a small distance, without changing the direction. Suppose this vector B, you cannot shift this vector B in this way because its direction is being changed. So shifting of vectors can be done through a small distance, without any changing direction. So this same vector B, suppose this is another vector C here. So this same vector B can be shifted here. See, no change in direction has been made. Now, yeah. Suppose this is your vector B. Then this same vector B can be shifted here. See, no change in direction. Shifting of vectors can be done. Free vectors. Okay. So vectors can be shifted through a distance, through some distance, without any change in direction. Is it okay? Yes. There will be no change in magnitude, or neither there will be no change in direction. There should be no change in magnitude as well as the direction, known as free vectors. Okay. So exercise 10.1. Let's see the exercise. In the first question, what do we have here? Represent graphically a displacement of 40 kilometers. Question number 1. Represent graphically a displacement
of 40 kilometers.
Displacement of 40 kilometers 30 degree east
of north.
That's just not when we have studied this kind of things in vectors. Okay, it's very easy. Yeah. So a displacement of 40 kilometers 30 degree east of north, we have to see this quantity has a magnitude 40 kilometers. It also has a direction 30 degree east of north. So it's a vector quantity, right? Displacement means distance with direction. That's displacement, so it's a vector quantity. The magnitude is given, direction is also given. Direction is 30 degrees of north. So we have to represent graphically. So this is your north, this is your south, this is your west, this is your east, right? So there should be a displacement of 40 kilometers east of north. East of north means 30 degree east of north. What does that mean? 30 degree east of north means 30 degree towards east starting from north. No? 30 degrees of north means 30 degree towards east starting from north. So this is your 30 degree, and the length of this line should be 40 kilometers. So this will be your displacement vector here. Okay? The length of your vector should be 40 kilometers. Length of the vector, length of the directed line gives you the magnitude. Is it okay? Here I cannot draw 40 kilometers in this board. So just 40 kilometers is represented by this directed line. The length of this directed line is the magnitude of the displacement 40 kilometers, and the direction is 30 degree towards east starting from so northeast. So your displacement is 40 kilometers northeast. Is it okay? So this is how you represent graphically. Very simple question. Let's see the other one. Question number 2. Let me just write this out quickly. What is your question number 2?
Classify the following
Okay, classify the following
measures as scalars and
scalars or vectors, right?
the
So
first
what are
set
the
of
quantities, physical quantities?
10 kg,
10 kilogram,
2 meters northwest,
2 meter
northwest,
northwest,
40 degrees,
40 degree east,
40
40
degrees only. 40 degrees only.
I don't
40 degrees.
Oh, 40 degrees. So this is Roman 1, this is Roman 2, Roman 3 is 40 degree,
Roman 4 is 40 watt.
40 watt. Watt.
Right.
Yeah. Next,
5 is 10 to the power minus 19 coulomb.
minus 19 coulomb.
Next is
Sixth one,
20 meters per second square.
20 meter per second square. Done, no? So what do you say? We need to classify which of them are vectors and which are not, right? So the first one, 10 kilogram, what does it represent? 10 kilograms. Yeah, what is 10 kilogram? What does this mean, 10 kilogram? Mass of an object. If it was wet, or 10 kilogram can be wet. Wet means it's always like downwards. So in that case, it would have been a vector quantity. But they didn't specify as mass or wet. So let's just understand this as mass. Is it okay? The one who wrote this question is a little bit weak in physics, I think. So mass. Mass means what? Amount of a substance, right? Is it okay? The amount of substance concentrated. So mass has no direction. Okay, so having no direction, it is not a vector quantity. 2 meter northwest means, what does that mean? You are going 2 meter towards west from north. Okay, so northwest. So this is your north, south, east, west. 2 meter northwest means you are going in northwest direction. Northwest means northwest means 45 degree towards west from northwest. Is it okay? Yes. So since we have a particular direction that is northwest, the body is going towards the northwest. Is it okay? So this is a vector quantity. Third one, 40 degree. 40 degree. Degree. No direction is specified. Only a value. How much? 40 degree. Right? So it is not a vector quantity because no direction is specified. Only the magnitude. 40 watt. 40 watt. What physical quantity is it representing? 40 watt. Power. Electric power. Electric power has no direction. It has only magnitude, no direction. Even current has direction, but it is not a vector quantity, right? Okay. Here, if there was current, then we would have thought of direction vector quantity, right? So power is not a vector quantity because it has no direction. Okay. Power means it has only magnitude. It has a certain value. What is the power of this bulb? Say, yeah, 9 watts. Okay, 14 watts, anything like that. So no direction. 10 to the power minus 19 coulomb. What does this represent? Charge, electric charge. Electric field has a direction, but the charge has no direction. Charge is a fixed quantity. Is it okay? Yes. So it is not a vector quantity because it has only magnitude. If it was electric field, then it has a direction. Electric field has a direction, so it would have been a vector quantity, but not the electric charge. 20 meter per second square. What does this value, physical quantity, represent? Acceleration. Acceleration means velocity upon time. Rate of change of velocity, del V upon t. Rate of change of velocity. So acceleration has a direction. Is it okay? So it is a vector quantity. Okay. Very important for exam. 6 marks. Yeah. 6 questions, 6 marks. Okay. Question number 3. What do we have in 3?
Same thing.
Let me not do that again.
Okay.
Hmm.
Identify the following.
Identify the following.
Yes. Co-initial equal or collinear but not equal.
Oh yes. Okay, we can discuss that. In the given figure, a square, no? You have a square in the given figure, and the sides of this square are represented by some vectors. Huh? So, vector A, B, C, D. Oh, they have a direction as well. So with the help of your NCERT textbook, let me... Okay, this side of the square is directed in this way, represented by vector A. This side of the square is directed in this way, represented by vector B. This side C is directed in this way, vector C. And this side is given by vector D following this direction. Is it alright? Yes. So identify the following vectors. So we have to check whether these A, B, C, D are co-initial vectors. Co-initial vectors. Class co-initial vectors means vectors having the same initial point. Roman 2, we have to see which of them are equal vectors. Equal vectors means their magnitude and direction are equal. Here the magnitudes of all the vectors are equal because the length of each side are equal, right? But we have to check the direction. Roman 3, collinear. Oh, collinear, but not equal. Collinear. Collinear means parallel. Okay? They may be equal or not. They may have different direction. They may have different magnitudes. But we need to check whether they are parallel or not collinear. Okay? So can you say which of them are co-initial vectors? Can you see any two vectors having the same initial point? Yes. What are they? Vector A has this initial point. Vector B has also this initial point, right? So vector A and vector D are co-initial. Here A and B, there are no co-initial because one is terminating, one is initial, right? Okay. Yes. Equal vectors. Two vectors are said to be equal if they have the same magnitude and the same direction. Here the magnitude of all the 4 vectors are equal because they are the side of the square. So you need to check for the direction. Yes. See, vector B is in this direction. Vector D is also in this direction. Both the vectors are acting downwards, right? So they have the same direction, also they have equal magnitude. So B and D, vectors B and D are equal. So vector B and vector D. What about the next one? Collinear, but not equal. Collinear means they have different magnitude, they have different direction. Yes. Here see, B and D, they are equal. Okay, so they are saying it should not be equal, right? Of course, they are also collinear, but equal again. But there is a condition not to be equal. So if I want a collinear vector, means I have to, but not equal, then we have to think of a vector which are parallel but in opposite direction. That is vector A and C. So vector A and vector C are collinear because they are parallel, but they have opposite direction. So but not equal. Is it okay? Yes. If they only say collinear, then you can write only B and D also. Is it okay? But due to the condition of not equal, we cannot write about B and D. Yes. Next one. Answer the following is true or false. Okay, we can say true or false part. So let's go for the next exercise, 10.2. So exercise 10.2. The first question. So compute the magnitude of the following vectors. Compute the magnitude. What class 9, 10 students making like compute. It's computerized. No?
Yeah, imagination level.
Yeah. So the first one is
Vector A is
okay, vector A is
I cap
plus j cap plus
K cap.
k cap. That means x component is 1, y component is 1, z component is 1, okay?
Vector B is
Vector B is
2I cap
2i cap
minus 7J cap
minus 7j cap
minus 3
minus 3. So we want to find out the magnitude of the given vectors. No? C vector C
1 by root 3I cap
1 by square root of 3i cap
plus 1 by square root of 3
j cap
minus 1 by square root of 3
k cap. So in the introduction class we have learned how to find out the magnitude. For the vector A, magnitude of A, magnitude, how do we represent? Just write the vector within the modulus, okay? But it's not the modulus function, alright? It's just a representation. And we cannot call this as bar, so I'm saying modulus. So magnitude of A means square root of component of x square plus component of y square plus component of z square. So that's square root of 1 plus 1 plus 1, that is square root of 3. Let me do it for the vector C. Magnitude of C is also given by the square root of component of x square. What is the component of x here? 1 by square root of 3 holding square plus component of y square, which is also 1 upon square root of 3, plus component of z square, which is minus 1 upon square root of 3 holding square. So that is 1 by 3 plus 1 by 3 plus 1 by 3. That is square root of 3 upon 3. That is square root of 1. So magnitude of C is 1. That means C is a unit vector. Is it okay? Because a vector with magnitude 1 is a unit vector. Alright? The next question. Hey, for maths uploading video is difficult because I cannot do all the questions like this. No.
Yeah,
Then you
it's
will
okay.
not learn anything.
It's okay if you don't solve. The next question is like, give the exam, write two different vectors having same magnitude.
Oh, write two different vectors having same magnitude. So, having same magnitude. Okay, let me teach you that. They may have opposite direction, but I want to. They will have different components. Vector A, vector B, they will have different components. But when you find their magnitude, they should be equal, okay? Suppose your first vector, let me take as, I don't know, what will I take? Okay, you can choose A and B to be any vectors, okay? But when you find out their magnitude, they should be equal. Their magnitude should be equal. Is it okay?
Next one, having same direction.
Having same direction. So there also you need to choose two vectors which have, they may have different magnitudes, but their direction must be same. Is it okay? That means you have to choose vector A and B. No, you have to choose vector A and B such that A will be equal to minus of B.
No. Same direction.
Same direction. Or same direction. Or same direction means, yeah, same direction means the unit vector of A should be equal to the unit vector of, I can give you that example. Suppose your vector A is 1 upon square root of I cap plus 1 upon square root of j cap. Suppose there is no z component. Okay? And your vector B, suppose 1 upon square root of 3 I cap plus 1 upon square root of 3 j cap. Let me make it more complicated. Writing minus here. And plus 1 upon square root of 3 k cap. Then I want to find out the unit vector A and B, and if they are equal, then they have the same direction. Okay? So unit vector A. Unit vector A will be vector A upon magnitude of A, right? Okay. This also you can, since this is very easy, so you can just try by yourself now. Just choose any vector A, choose any vector B. Okay, I don't want to like waste time doing this, thinking about this. Just find A cap. A cap means magnitude of A upon your vector A. Unit vector B means vector B upon magnitude of B. If you can show that A cap and B cap are equal. A cap means unit vector representing direction of vector A. B cap means unit vector representing the direction of vector B. So if these two, A cap and B cap, are equal, then they have same direction, right? Okay? Yes. Next.
We have given two vectors which are equal, and then they are telling to find x and y in one vector.
Okay, let me write it. Question number 3.
Okay.
Or there will be question number 4, right?
Yeah.
So can you dictate the question?
Find the values of x and y
Find x and y
so that the vectors
so that the vectors
2i cap plus 3j cap
2i cap plus 3j cap
and
and
xi cap
xi cap
plus 1
y j cap
are equal.
are equal. That means both the vectors are lying in xy plane, because there is only x and y components. So both the vectors are lying in xy plane. And also they say that these two vectors are equal. Is it okay? Now we know that two vectors are equal if they have the same magnitude as well as same direction. So using that concept, you can find out. Okay. Only hints. I will give you only hints. So it's given that, okay, let your vector A be equal to 2i cap plus 3j cap, and your vector B to be equal to xi cap plus y j cap. So if these two vectors are equal, they have same magnitude as well as the same direction. That means magnitude of A is equal to magnitude of B. Is it okay? So using the relation for equal vectors, you can like find out x and y. Is it okay? Yes. Next one.
Find the scalar and vector components of the vector with initial point and final point.
Find the scalar and
Vector components.
vector components. Question number 5. Find the scalar and vector components. Vector components. Find the scalar and vector components of the vector. With initial point 1. With initial point 1 and final point Yes, I'm holding the textbook. -5, So final point is not correct, it should be terminal point. They have also given terminal point. Terminal point. Now, find the scalar and vector components of the vector with initial point 2, 1 and terminal point minus 5, 7. So let your initial point, let A be the initial point. Let the initial point be A. Let the initial point be A with coordinate 2, 1. And the terminal point be B with coordinate 5, 7. So you want to find out vector AB, right? In order to find out vector AB, how do we do? Position vector of B minus position vector of A. Position vector of B, how do we represent? Vector OB minus vector OA, right? Is it okay? Okay. Now, for the point A, its position vector OA will be represented by 2i cap plus j cap, right? And for the terminal point B, its position vector will be represented by vector OB minus 5i cap plus 7 j cap. We don't require this. So these are the vector components of the two given points. You want to find the scalar component. Their scalar component means to find out the magnitude of OA, right? So that will be square root of component of x square, component of y square. That is 4 plus 1 square root of 5, right? So this is the vector component of A, scalar component of A. Oh no, vector component of A, scalar component of A, yes, correct. And for the same point B, your vector component is position vector of B. That is the vector component of point B, okay? And its scalar component will be the magnitude of the position vector, right? Scalar component and the vector component means vector form of this one. This is your initial point. Vector component means they are asking you the position vector of this point. Vector component means they are asking you the position vector of this point. Scalar component means you find out their magnitude. Is it okay? It will be square root of minus 5 square plus 7 square. 25 plus 49, how much will that be? 70. Can you check the answer? Oh, they may be asking you vector AB. Oh, initial.
Minus 7 of 6.
Huh?
Minus 7 of question number 5.
Okay. that means you want to find out the scalar. Okay, let me draw the figure. This is your plane, no? This is your plane. This is your x-axis. This is your y-axis. Your initial point is A, 2, 1. And your final point is B, terminal point is B, minus 5, 7. So you want to find out the scalar and vector component of the vector with initial point this one and terminal point this one. So this will be your vector with initial point A and final point B. Now, are you getting me? This is the problem of not reading the question carefully. So you want to find out a vector with initial point A and terminal point B. So a vector with initial point A and final point B will be given by vector AB. And vector AB means position vector of B minus position vector of A. So the position vector of A will be given by your vector vector OA. Now, position vector of B will be given by vector OB. So you need to find out the scalar and vector component of this vector here. This vector with this initial point and final point, okay? Because this is the only vector with this initial point and final point, this one, right? Okay? Yes. Question, brother. Find the scalar and vector component of this point. Now, they are talking about a vector having this as the initial point and this as the final point. That will be your vector AB, okay? So vector AB means position vector of B minus position vector FA. Okay, class, what is the position vector of B? Position vector of B will be minus 5 I cap plus 7 j cap. Position vector of A means OA, 2 I cap plus j cap. So your OB will be minus 5 I cap plus 7 j cap. Minus, and what is your position vector of A? 2 I cap plus j cap, na? I cap plus 7 j cap minus 2 I cap minus. It will be upload no comments still no minus 5I minus 2I minus 7I plus 6. So this is the vector component of a vector having this initial point and this final point, okay? Scalar component भी लगे ना? Scalar component means what? ताई लगा magnitude. You know ताई लगा magnitude हो बोलो? Square root of component of x square plus component of y square. 49 plus 36 किमान होगा? 80 square root of 85 in the scalar component. Okay? Alright. Still going on or what? Okay, next. The questions which you can do, you can skip and tell me the one which you cannot do. Ne? I think that will be better. What is the time?
It's about to be 8.
About to be 8. And we
10
still
minutes
have time.
time.
We still have time.
Yeah.
We can do more time. Question number? Yes.
Find the sum of vector 이렇게 되죠.
어려워나?
Unit vector of the 이렇게 되죠. Find the unit vector interaction of vector PQ where P and Q are both similar with 5 find unit vector 이렇게 되죠.
I'll put off the. I'll pause. Hey, the upload no video. Number 12, no? Because if I need to upload, I have to do each and every question. And if I do that, then there is no use of learning, no? Find the direction cosines of the vector I cap
plus
2j cap
3
plus 3. Okay, you want to find out the direction cosine. Now, I told you I didn't show you how to work out. You have already understood what are direction cosines, but I didn't show you any problem relating to finding the direction cosine of a vector. No. Yes. So the direction cosines of the given vector. Let A be your unit. Let A be the vector. Let A be your given vector I cap plus 2j cap plus 3 k cap. So the direction cosine of this vector A will be given by for a single vector. Now this is a single vector. So the direction cosine of this vector will be given by vector A divided by its magnitude. Direction cosine. Our direction ratios x, y, z. X, y, z to direction ratios. What is the x component here? 1. What is your y component? 2. What is your z component? 3. So direction ratios direction ratios of A are 1, 2. Will be direction cosines for a single vector in a capital. So your vector A is I cap plus 2j cap plus 3k cap upon magnitude of 1 square plus 2 square plus 3 square upon the magnitude of this vector, that is square root of x component square plus y component square plus unit vector. Kilo kule direction ratios of A means style angle pisari asido na. Angle means direction ni asido. So I cap plus 2j cap plus 3k cap divided by kima noboido 9 plus 4, 13 plus 1, 15. No? So that will be 1 upon square root of 15. 9 plus 4, 13. 13 plus 1, square root of 14, right? 1 upon square root of 14 I cap. 2 upon square root of 14 j cap. Plus 3 upon square root of 14 k cap. Therefore, direction cosines. Direction cosines are 1 by square root of 14, 2 upon square root of 14, 3 upon square root of 14. Is it okay? Yes. That means if this is your vector A, then the cosine of this angle is this much. Cosine of this angle is this much, and cosine of this angle is that much. Our direction ratios ko like XYZ component 0 direction ratios ko. XYZ are your direction ratios, right? Yes. Can you check the answer?